Hi everyone, thanks for tuning in to the Fangamer and Bookmans event stream, Introduction to Video Game Development. I'm your host, Jack Murphy. I've been dabbling around with making video games ever since I was a little kid with like RPG Maker, and eventually moving on to 3D games using the source engine, things like Gary's Mod, Half-Life, stuff like that. And in the last couple of years, I've been working on my own game at Fangamer as a game designer. Tonight, Fangamer and Bookmans has given me a chance to help open the doors to the world of game design to people who maybe don't really know where to begin, who are aspiring to become game developers but aren't quite sure what the first step should be. I feel that game development is within a lot of people's reach who may not realize it. If you are really passionate about this creative idea that you've had for a long time and you want to find a way to express it and you feel like video games is the perfect medium for it, I want you to be able to walk away from this stream feeling empowered that it is something you can do. That if you're willing to put in the time and the effort, that it is not impossible, that it is within your grasp. And I plan to do that by introducing you to the Unity game engine, and over the next 2 hours or so, showing you the basic concepts and workflow that goes into making a game. And at the end of the stream, I'll have several resources that you can use to continue your learning from here. And I'll also have suggestions for both paid and free-to-use software to help build your game. Again, this is a lot of ground to cover in a relatively short amount of time, so I'm going to be moving at a pretty fast pace. If you can't keep up, that's completely fine, I understand. Just go ahead, feel free to pause the video and catch up. If you don't want to pause the live stream, this video will be uploaded later so you can review it and go at your own pace later on. Also, despite this stream not being live technically, I am in the chat right now. So if you have any questions for me, please just ask them in the chat and I'll do my best to answer them. When this video is uploaded to YouTube, I'll also include a Google Drive link in the description where you can find notes for this class. All right, without further ado, let's get into it. All right, so to start a new project in Unity, we're going to need to open up the Unity Hub. If you don't have the Unity Hub or Unity for that matter installed, check the description below or see the link in the chat for the primer video that will walk you through setting yourself up with a Unity ID and installing the Unity editor. But moving on, I'm going to assume that you've done that already and we'll get started. So here's Unity Hub 3.0.1. It's the latest version as of this recording. When you first open up Unity Hub, you'll see that it opens to the projects category here. This is where you'll have all of the games you're working on in one place. There's multiple reasons why you may have multiple Unity projects going at once, but more often what I think is going to happen is as you're learning to make games for the first time, you're going to constantly be learning new things every day, and you're going to be finding more and more inspiration coming to you very, very quickly, and it's going to be very tempting to start new projects one after the other. Aside from managing all your current projects, the Unity Hub is also very useful for managing installations of Unity. It's pretty common to have multiple versions of Unity installed on your computer at any given time. As you can see here, I have 4 of them. The top one here is the latest version of Unity specifically for this lesson. One I have installed because I'm still working on a game that I began in 2020. And this last one down here I use for making VR chat worlds. Now, whatever your reason is, the Unity Hub makes it very easy to install and manage different versions of Unity. Well, let's go back to the Projects tab for now. And let's start a new project. Up here in the top right, you see this blue button. Click that. Up here, we can select the version of Unity we want to use for our project. Looks like the latest one is already chosen. And then we choose a template to use as a starting point. There's 3 categories of templates right now. There's the core templates, which are bare bones. They're the Unity editor set up for very specific types of games, such as 2D, 3D, VR, you see here, third person, first person, and mobile. After that, you have samples. The samples provide templates that are a bit more advanced. You have the HDRP and URP 3D samples. The HDRP stands for the High Definition Render Pipeline, and it is reserved for the large studios. I would not recommend working in HDRP unless you yourself are a technical graphic artist or you have a team where you can have someone who's specialized in creating shaders and stuff for your game. The URP stands for the Universal Render Pipeline, It's kind of like HDRP, but it's lighter weight and it's more accessible to indie devs. However, I would not recommend even the URP for beginners. And last, we have the Learning tab, which are small games that are all completely made, and they're here for you to be able to look at the inner workings of them and essentially reverse engineer them to figure out how they did it. But for our purposes, we want to go with the bare basics. I'm going to be working in 3D, so I'm going to go back to our core templates here, and I'm going to choose the 3D core. All right, next after that, on the right side of the window here, we have our project settings. You can put in your project name. I'm just going to go ahead and call this one tutorial, but feel free to name it whatever you'd like. Next, click down here to choose where you want to save. As you see, I have a dedicated Unity projects folder. That was not made by Unity when it's installed. I made that myself, and I recommend you find someplace on your computer where you can keep all your projects. My computer only has one hard drive on it, so I had no choice but to install on the C drive. However, if you're on a desktop computer with multiple hard drives, preferably in the terabyte range, I would suggest putting your Unity projects in there, as Unity projects can grow to pretty big sizes very fast, especially depending on what kind of game you're making. So I would recommend saving to a different drive other than your C drive, one that has a lot of space to make room for growth. So once you have your location set and your project name set, go ahead and click Create Project. This is going to take a little while. It's going to be running in the background for a little bit. So I'm going to take this time to discuss game engines, a brief introduction to them and how they work, so you have a better idea of what Unity is. All right, game engines. A game engine is essentially what powers your game. It is the foundation and the framework that everything is built off of. I would describe a game engine as being comprised of 6 major elements. The first one is the programming of the game, or game logic. Game logic defines what type of game you're making. If you're making a sports game, you'd use game logic to determine when a goal is made. If you're making a racing game, you'd use game logic to control the car physics. First-person shooter to determine where a shot lands, and an RPG would use game logic to define and develop its combat system or create a fun, interesting way to explore the world. Next is audio. It's everything the player hears. This encompasses sound effects, background music, audio cues, voice acting, everything. And then you have 2D art. This is the surface of the game. This is the feel of your game. Think textures, sprites, even user interfaces. Things like menus and heads-up displays all fall under the 2D art. And then 3D models. Models give depth to your game. The world geometry, the land, the buildings, the trees, the things that populate the world, the items, characters, even some special effects can be created using 3D objects. And then we have player input. This is what the game reacts to. Without it, anything you make in Unity is essentially just a screensaver. There's lots of different varieties that player input can come in. The most obvious are game pads, game controllers, or mouse and keyboard. Although lately there's been more and more kind of exotic types of player input. For example, Phasmophobia uses your computer microphone to let you talk to ghosts. The game Before Your Eyes uses your webcam to track when you blink to advance the game. And VR headsets allow you to become fully immersed in the game world. There's so many different types of player input out there, and by exploring those, you can really start to discover new ideas for games you may want to make. And then finally, output. The game engine takes all those 5 previous elements, processes them, runs the math hundreds of times a second, and outputs the game that we experience. Well, with that said, it looks like our game engine, the Unity editor, has finished setting up. All right, here we are. This is the Unity editor interface. Seems a little empty at the moment, but that's all right. I'm going to be spending the next couple minutes here describing each of these windows, and then we'll be moving on to actually creating something, and you'll start seeing things populate and come alive soon. All right, the first window that is the most eye-catching is probably the one right here in the middle. This is the scene view. A scene can be thought of as a game level. Scenes can be as small as a phone booth or as large as the entire world. It really depends on the type of game you're making. But this window here is how we look into that world. Next is the Game tab. The Game tab is a preview of the game itself. When we click on the game tab here, we're seeing what the player will see when they play our game. Right now it is looking through the main camera. If we go to the scene here, you see that there's a little camera icon down here and a sun. When we go to the game tab, we are seeing through that little camera object down there. Anytime while working on a game, you can play test it by clicking on the big play button up here in the middle. I'll do that now. And you'll see that most things gray out. However, the scene view has switched to the game view on its own. Nothing's happening because, well, our game's pretty empty right now. So we're going to go ahead and click the play button again to stop, and it switches back to scene view. Over here on the left, we have our hierarchy. The hierarchy shows everything that is in the scene. Like you see here visually, we just have a camera and a sun. You can see these reflected here as the main camera and directional light. I can click on these and you'll see them get highlighted over here, selected in the scene view as well. And I can click in the gray space here to deselect. Alternatively, you can also hold down Control and click on whatever you have selected to deselect. And all the way on the far right side of the screen here, we have the inspector. The inspector gives us a detailed look at any objects we have selected. We don't have any right now, so let's go back to the directional light, and we can see the inspector become populated with all this information. Different settings, parameters, all these things that we can use to edit this light and make it our own. And then at the bottom, we have the project window. You can think of this as a file browser for everything in your game. This is where you'll be storing all your assets. When I say assets, I mean the creative works that make up your game. Things like your textures, your music, your sound effects, your 3D models, your programming scripts, everything. Everything will be stored in your assets folder in the project. Also, as part of the project window, you see there's a tab here for the console. The console is a way for Unity to talk to you. If there's something wrong with your game, it'll present an error here. If there's any warnings or debug messages you want to leave yourself from the game, they will all appear here. It is useful while using the editor, but most of the messages you'll get with the console is when you're playtesting your game and tweaking it. But for the time being, I'll just leave it on project. All right, so that covers the main areas of the Unity editor. Again, to recap, we have the scene and game view, the hierarchy, the inspector, and the project, as well as console windows. Now that you're familiarized with the Unity editor layout here, we can begin talking about two fundamental concepts for creating in Unity: game objects and components. First, we'll start with game objects. Every tangible thing in your game is created from a game object. That's the first thing you should conceptualize in your brain. If you can see it, if you can touch it, if it has a presence in your game world, it is a game object. Back when I said that the hierarchy here lists all the things in a scene, these things are game objects. This camera, this light. Eventually, when we start making a level, when we start having, if you're making a game and you have a main character or NPCs or item pickups or vehicles, like all that stuff is going to be made from game objects. Later on, as we continue through this lesson, we're going to be doing things like creating a small level. We're going to be creating an object that we can control with the keyboard. All these things are going to be game objects. So let's look about how we make our own game object. It's very simple. You just right click here in the hierarchy and you go down to create empty. There you go. We have our first game object. I'm just going to go ahead and keep it named game object, and I'll just hit enter. In its most simple base form, a game object consists of two things. If we look up here in the inspector, we have its name and its transform. The name is essentially mostly for your sake. It allows us, the human working on the game, to quickly identify what an object is. Like if this was the player, I'd name it player. It's not, so I'm going to control Z back to game object. The second thing that a game object has is its transform. A transform is a game object's position, rotation, and scale in 3D space. Game objects are given functionality by attaching what are called components. Components are essentially packets of code that allow the game object to make changes to itself and others. When I click on things like the sun or the main camera, we can see components on these. The main camera and the sun originally started off as empty game objects, but then we're given components which then defined how they behave and what they are in our world. As we see here, the main camera has a camera component, not too surprising, and an audio listener component. Obviously, the camera component is what captures the world and renders it onto our monitor. The audio listener is what takes in sound from our game world and plays it through our speakers. We click on Sun. The Sun has a light component. That light component has settings, such as the type. We can change it from directional, which acts like a sun, to spot, which would be like a spotlight, or point, which would act like a light bulb without any sort of shade on it. These two game objects, though wildly different, both started from empty game objects. It's their components that define them and give them unique functionality in the game. Eventually, we'll be able to create our own components, and that's called scripting. This is how you program and create game logic for your game. The idea of scripting and programming is way too advanced to all fit into this one lesson. However, I will be doing a small demonstration near the end so that way you can see it, see the workflow, and kind of get an idea of what it's all about. Okay, we've done a lot of talking about abstract concepts, but the best way I think to truly grasp them is going to actually be able to work with them. So let's get started. The first thing I'm going to want to do is I'm going to create a platform, a stage for our game. To do that, I'm going to create a simple game object, a cube. Unity has lots of pre-made game objects, very much like the camera, the sun. They're just empty game objects that have been pre-configured with components. To quickly create a cube, we just right-click in the hierarchy like as if we were creating a new empty game object. But instead of creating an empty one, we go down here, 3D object. This is a list of game objects that have already been set up with several components for useful shapes and tools. Up here at the top, we see cube. Click that, and there we are. We have a cube. We see it in the scene view. If we look at the inspector, we can see that it contains 3 components: a mesh filter, a mesh renderer, and a box collider. You may notice this default material down here at the bottom. That isn't actually a component. That's just part of the mesh renderer, and we'll be touching on that later. The main thing to take away from is it has the transform component, which all game objects have. And then the mesh filter and mesh renderer work together to actually create the 3D cube we see on our screen. And this box collider is essentially the hitbox of our cube. This defines the space where objects will collide with it. Without the box collider, things would just pass through it. And without the mesh renderer, we wouldn't be able to see it. Now that we actually have a tangible object in our scene, this might be a good time to show how to navigate around, fly around your level, and inspect things. All right, in order to fly around our level, you simply right-click and hold anywhere in the scene view, and then move your mouse around. As you can see, you kind of look around as if you were in first person, and then you can use WASD to fly around. W is forward, A is backwards, S and D is strafing left and right, and Q and E lowers and raises you respectively. So, using these in conjunction, I can move around my scene, get a good look at this cube. I can fly off into the distance if I wanted to. You can hold shift to move even faster. And yeah, this is actually a good example here. If I fly way, way off, I can get lost. Depending on how big your levels are, it could be very easy to get lost here. So now I have no idea where my cube is. If you ever want to get yourself repositioned in the scene view, just select an object from your hierarchy. Like I'll select on the cube, and then I'll hit F on the keyboard and it'll frame it in the middle of the screen. There we go. And now I can continue flying around. Aside from the sort of free look fly around mode, there's also orbiting. The orbit is useful for easily inspecting objects from all angles. I'll go ahead and click F to reframe the cube in the center. And now to orbit, I hold down Alt on the keyboard and then left click and drag. And this allows me to just spin around the selected object. And I don't have to worry about WASD. It's just one button, Alt, and then just your mouse to fly around it. There we go. So using these two methods, you can very quickly move around your scene and inspect things and see it from all angles. Moving on, we're now going to move and shape this cube and turn it into a platform by transforming it. Before we do this, I'm going to give you a little crash course in 3D space in case you need it. Okay, 3D space. What does 3D stand for? 3D is 3 dimensions. Left, right, up and down, and forwards and backwards. Most 3D applications refer to these directions or dimensions as X, Y, and Z. X being left and right, Y being up and down, and Z being forward and backwards. Unity measures the distance in either direction in what's called units. Each unit in Unity is roughly equal to about 1 meter in the real world. So if I said here that the cube is located 1 unit on the Z-axis, I mean that the cube is 1 meter forward of the origin of the level. The origin being right here, the intersection of the X, Y, and Z where everything is considered 0. I'm going to go ahead and I'm going to type maybe 2 in the X, which means it's now 1 meter forward and 2 to the right. And then I'm going to do -1 for the Y, enter. So now it's 1 unit forward, 2 to the right, and 1 down. I could put 0 here in all these fields to return it to the center. Hitting the W key on your keyboard while having an object selected will open up the position gizmo. The gizmo allows you to quickly move things around by hand. I can just grab an arrow here and I can move things around by hand, and as you see, it's updated here in the inspector. I'm going to again return this to the center just so it's easy to keep track of. After position, we have rotation. The hotkey for the position gizmo is E on your keyboard. Now our gizmo has changed to sort of these spheres, these rings. I can rotate it on the Z dimension. Instead of being called the X, Y, or Z dimension, they can also be called the X, Y, or Z axes. I can do the Y axis on the green, and I can do the X axis on the red. I can also click in between all of them and I can just move it around freely. I'm going to go ahead and set these back to 0. And last is scale. The hotkey for that is R. So if you've been paying attention, W, E, R. They're all right next to each other on the keyboard. W for position, E for rotation, and R for scale. So going back to scale, scale is the size of the game object. I can click and drag the Z part of the gizmo, and you can see it gets longer or shorter. I can grab the X axis, and you can see it gets wider or thinner. And finally the Y axis to make it taller or shorter. And these again can all also be edited by hand in the inspector. Unlike position and rotation, where 0 is the default value for them, 1 is the default value for scale. Think of 1 meaning 100%. So if I wanted to do half the size of the cube, if I wanted to make a cube that was half the length in each direction, I would do 0.5 for each one. And if I wanted to make it disappear completely, I'd do 0. So that's why you don't want to have your scale at 0. You want to keep your scale at 1 if possible. That should be enough talking about the basics of 3D space. Let's get to work actually creating a platform here. To make a platform, I'm going to want to make sure that the top of this cube is level with the ground. Knowing that the cube is 1 meter on all sides, we know that the cube is ½ a meter above and ½ a meter below the center of the level here. So in order to get the top of the cube flush with the ground, we simply have to lower it by ½ a meter, -0.5. There we go. I can orbit around the cube, and yeah, there we go. It's right on the grid there. And now we need to make it wider so things don't just fall off of it. Not much of a platform like that. So I'm going to select the X dimension for scale, and I'm going to increase it to 10. I'm going to do that again for Z, the length. So now width and length are both 10, and we have a nice wide platform to start on. I'm also going to rename this game object. I can either do that by selecting it and then clicking a second time and then typing it in, or I can simply right click and go down to rename. I'm going to name this platform. So that's how you create a simple game object and then transform it to get the position, rotation, and scale that you need it to be in. Next, we're going to make another simple game object, but this time we're going to start messing with the components, adding new ones, and essentially we want to create a separate cube that will be physically simulated and have it fall from the sky and land on the platform. So to begin, let's create a new cube. So we're going to right click, go down to 3D objects, and click cube. I'm going to just go ahead and keep it named cube for now, and I'm going to hit F to zoom in on it. And it appears as if this cube has been created inside of the previous one. If we go up to the inspector here, we see it's already half a unit down, which makes it perfectly aligned with our platform. That's not good. So I'm going to hit W to switch to our position gizmo, and then I'm going to drag it up. Having this sunlight here and dynamic shadows really helps us get an idea of presence, like depth. This cube feels like it's floating off the ground here, seeing that shadow. However, it does still blend in a little too much with the platform, both being white like this. Like from this angle, if you don't see that shadow there, it makes it, oh yeah, it's almost completely lost in the platform there. So let's take a little break here and let's play around with what's called materials. Materials are essentially the paint that is used on almost everything you see in a Unity game. Some examples might be textures on a 3D model, 2D sprites, and UI elements. So by creating a new material, we can give this cube a different look than the platform, making it very easy to visually distinguish it. So this material is going to be our first custom asset for our game. As you work on a game, you will develop and create many materials, so it is important to keep them organized. Let's do that right now by right-clicking in our assets folder in the project window here and going up to create folder. We can create a new folder within our assets and we'll call it materials. Double click to open it up. And now that we're in this folder, we can right click, go up to create, and then a little above halfway, we have material here. There, we've created our new material. I'm going to leave it as new material for right now. We can rename it here in a moment. With our new material selected here, we see that the inspector has changed. This allows us to define our material. Materials as well also deserve their own lesson to properly cover, but here's the rundown. The look of a material is defined by 2D art files that are called maps. The main one up here being the albedo map. The albedo map is what you would traditionally consider a texture. It contains all the color information for your material. And that's really the only one that we're going to be working with tonight. There's many more here like metallic, normal map, height map, occlusion, detail mask. And these are all very powerful, and when used in conjunction can create some very professional looking materials, very lifelike objects. But for this entry-level lesson, we're just going to stick with albedo. I already have a 2D texture downloaded. I'll open that right now. I'll go to my downloads folder. And here it is, the Unity logo. Very simple, but a texture nonetheless. I'm going to return to our assets folder. We have this little folder structure representation up here. I can click on assets to go back there. I'm going to right click, create folder, and I'm going to name this one textures. Open it up, and I'm going to open up my file explorer again. And I'm going to just simply click and drag my Unity logo JPEG here into my textures folder. And Unity does all the work for me and imports it. Now, before we can use it, we have to go back to our material, new material. And now on the albedo map here, this little tiny circle next to it, I can just click on that and it'll open up a file previewer. This lets me see all the textures I have in Unity. I can use the search bar up here to find one in specific, but as we only have 11 or so, it's not too hard to find our Unity logo. I'll double click that, and it has now been set as our albedo layer. Down below, we have a sort of preview model that we can see what it'll look like on objects. This is what our material looks like right now if we were to put it on a sphere. Looking good. And you know what? I think that is good enough to get started. Now let's apply it to our cube. Putting a material onto an object in Unity is as simple as clicking and dragging. If I put it over the platform, it's applied to the platform. If I put it on a cube, it's on our cube. I release and it's applied. Now I can make sure I have the material still selected. I can go ahead and make changes to our material here and it'll be updated in real time on whatever objects have this material. I'm going to go ahead and take this material and I'm going to change its name now. I'm going to call it just Unity logo. Pretty descriptive. And now before we finish up here with materials, I'm also going to change its color. The albedo layer can be colorized using the hue over here. Right now it's just set the white, which if we had a color texture, like if this was a red brick wall or something, I'd want to keep it white because it would keep all the colors exactly how they are in the 2D art file. But since this is a black and white image, I can very easily change the hue and it'll look good. So let me click on this white swatch here and it opens up a color picker. Right now it's on white, but I'm going to go ahead and I'm going to slide it up to red. There we are. I can right click in the scene view, fly around here, get a little closer look, click on the color here, and I can go ahead and change it, and I can create a whatever color cube I want here. You know what? I kind of like this blue here. Yeah, let's do that. There we are. Nice. I'm going to change this name now to be Unity Logo Blue. All right, now we have a cube that stands out from the platform under it. Now our next step is to make it fall. If I hit play right now, nothing's going to happen. The reason for that is that this cube, I can't select it in game mode. I have to switch back to scene view in order to select things, but you can select and change things while it's in game mode. But as we can see, this cube, like the platform, only contains a mesh filter and mesh renderer for viewing the cube, and a box collider, which lets things collide with it. There's nothing in here that simulates physics. I'm going to go ahead and stop playing. And I'm going to raise my box up a little more. And now I'm going to add a component that will allow those physics calculations to happen when I hit play. I'm going to go down here to the bottom of the inspector where you see an Add Component button. Click that and you can start searching for new components. The one that enables physics is called Rigid Body. I start typing it and there it is. We have Rigid Body and Rigid Body 2D. Rigid Body, the plain one here, is used for 3D objects. Rigid Body 2 is used for 2D objects, obviously. I'm going to go ahead and click Rigid Body, and it's added. We can change things like the object's mass, its drag, whether or not it's affected by gravity. That sounds useful, as well as other more technical things here. But honestly, that is really all we should need. To better see this effect, I am going to raise our cube higher up in the air. I'm going to raise it to about 8. There we go. Now when I hit play, we should see our block drop from the sky. All right, perfect. So it did what we wanted. However, that wasn't super visually interesting, was it? Just kind of fell down and stopped. What we're going to do now is I'm going to create something called a physics material, and I'm going to apply it to our cube to make it bouncy. A physics material is an asset, so I'm going to go back to our assets, and I'm going to right-click, create a new folder, and I'm going to call this a physics material. Go in here, right-click, create, and then about 3/4 down, we see physics material. There we go. I'm going to name it Bouncy. I already know what I want the purpose of this physics material to be, so I can give it a name. Going up to the right, we see the properties of our physics material. We can change things like its different types of friction, but most importantly for what our needs, the bounciness. 0 means no bounce, and 1 means complete bounce. It'll bounce forever. I don't want it to bounce forever, so I'm going to do something close. I'm going to do 0.95. Enter. That should make it fairly bouncy without it being obnoxious. Next, we need to add it to our cube. So let me click on the cube, and physics materials are handled by the box collider. So underneath the box collider component here, it's looking for a material, specifically a physics material that we can see here. We can either click and drag from the projects window here right onto the field. There it goes. Or we could click the little target on the right, and that'll open up, again, a little file browser that we can use to find our physics material. But we already have it set, so no need to do that. Let's test it out by hitting play. Very nice. Okay, that's more what I was looking for. We can make this even more interesting. I'm going to hit hotkey E on my keyboard, and that'll allow me to rotate. I'm going to position it to land on a corner. That'll give some more kind of wild, unpredictable bouncing when it hits. Let's hit play. Whoa, there we go. That was pretty satisfying. But I think we can do better. All right, so my next idea for making this more visually interesting is going to be adding a light to the cube. Adding a light source to the cube will look really neat as the cube falls from the sky and gets closer to the platform. We'll see the effect of the light become more pronounced. And as it bounces, see that light source move and reflect off of the surface of the platform. So to start, we're going to create a new light. We're going to right click in the hierarchy, and we're not going to do create empty, not 3D objects, but light, and then point light. All right, we can't really see what this looks like right now because the sun is so bright. Let's go ahead and turn the sun off. We can do that without having to delete the sun in case we want it back. We can select sun, and then this little toggle box right up here to the left of its name, just uncheck that, and that should turn off all the sunlight here in the level. Now I can select this point light here, and I can move it over and down, make it closer to the platform. There, and I can actually see how it'll look as it gets close to this platform. As you can see, I move it up, it gets softer. If I bring it down, it gets harder and kind of brighter there. So yeah, this will look really neat as the cube is sort of bouncing around here. So let's put this light in the middle of the cube. I'm going to do this quickly by selecting the cube, going over to the transform component, click on these three dots, and a context menu appears. I can drop down to copy world placement, click on our light, go to its transform component, the little context menu here, and instead of copy, paste world placement. There, so the position, rotation, and scale are all the same of the cube. There we are, right there in the middle. So now, let's test it and see how this is not going to work. I hit play, the cube falls, but there's no light. I can switch back to the scene view and see that the light is still floating in the air where it originally started. We can easily cause the light to join with the cube. In order to do this, we simply click and drag the point light onto the cube. This is called parenting. What we have done is we have parented the point light to the cube. What this means is the cube is the parent of the point light, and the point light is the child of the cube. That kind of makes the hierarchy name here make more sense. The way parenting works, parent and child game objects, is the child game object inherits all of the transformational information from its parent. And what that means is that the point light is able to move independently of the cube. However, if the cube moves, it takes the light with it. Parent objects also have these nice little collapsible arrows next to them, so I can click on this and it hides the light. Click on it again and I can see all of its children. So as you can see here, the child object is indented a little bit as well. All right, so let's see this parenting being put to practice. I'm going to go ahead and hit play. And there we go. Now the cube casts a nice bright light whenever it's close to the platform. And again, to reiterate, it is doing that because the point light is a child of the cube. If I go to the scene, I am able to move the light independently and it will not move its parent. However, if the parent moves, the child moves with it. I hit play and everything resets back to where it was beforehand. That looked really nice, but I'm still not too happy with it. As you can see here, I'll hit play again. It creates a nice light effect, but the cube isn't glowing, so that light looks kind of unnatural. Let's go back to our material, our Unity logo, and I can give it light by clicking the emissions checkbox here. I'm going to go ahead and click the color swatch here, and I can choose a color for it. There. If I go full, as bright as it can be, we don't see our texture anymore. So I'm going to make it slightly dark, so that way the Unity logo still comes out. There we go. I'm going to go ahead and hit play again. There, that looks better. That looks more like it should be emitting light. All right, we're starting to head into the last stretch of the lesson here. However, we still are missing one of the crucial elements of what makes a game a game. We have our game logic. We have the components that make the cube fall. We have components to make it glow. We have basic game logic. We haven't added sound yet, but that's coming. We have our 2D art in the form of the texture on our cube. We have 3D models in the sense of the cubes that make up our world. But as it stands right now, this is still just a screensaver of sort. We can just watch it. So let's start adding some game logic to accommodate for player input. What I want to achieve before the end of the night is I want to make it so that way the player can move the cube using WASD on their keyboard and have the cube jump by pressing space. Right, if you've been following along this far, great job. I'm proud of you. But moving forward, we're going to be covering a lot of complicated ground, and I don't expect a lot of people to actually be able to follow along with all this. I still think it's very useful to watch because it gives you an idea into the workflow and concepts and sort of makes programming a little less scary, I hope. That was the biggest thing for me getting into video game development was programming. I always thought it would be too hard, too complicated for me to really wrap my mind around. But once I actually tried it and saw how it worked, things started clicking. And I'm hoping that even though you may not be able to follow along perfectly, that you'll still be able to see, hey, this isn't that hard. I think I could get the hang of this. And again, if you were able to pause the video, rewind, I do think you'll be able to follow along, and the amount of endorphins you'll get when you are able to create your own line of code and see it affect the game in real time is phenomenal. So I apologize if I'm going a little too fast during this part and if it seems a little complicated, but please bear with me and don't get discouraged. All right, let's begin. Step one, if we're going to have this cube rolling around, bouncing around, it's going to fly off the platform, no doubt. So the first thing I'm going to want to do is I'm going to want to cage in this cube. I don't want it bouncing off the platform into the void. So to do that, I'm going to fly around in our scene view. I'm going to select my platform and I'm going to hit Control D on my keyboard to duplicate it. Now using the gizmos and the transform component here in the inspector, I'm going to rotate this cube 90 degrees on the X axis to have it stand up straight. And then I'm going to roughly move it into position so that way the corners meet. Good, and then I'm going to manually type in rounding up to the nearest units to make it nice. So that Y looks like it should be 5 and the Z should be 5.5. There we go. Perfectly, these edges line up. Lovely. All right, I'm going to rename this platform from platform 1 to wall. Then I'm going to hit Control D to duplicate. And now I can quickly move it over to the other side by putting just a minus sign in front of the Z value. So now it puts it on the opposite side of the origin point here. I'm going to Control D again to duplicate. And I'm going to move it here. I'm going to rotate it on the Y axis to make it go sideways. And I'm going to put it to 0 on the Z. And 5.5 was the magic number for those other walls. And then I'm going to Control D again. And once again, put the negative in front. All right, awesome. We have all of our walls. And finally, just a roof. I'm going to select the platform at the bottom, Control D, move it all the way up to the top. And right around there, looks like 10.5 is where we want to be, 10.5. There we go. The cube isn't going anywhere. However, we have a big problem now where if I hit play, we don't see a single thing about what's going on in there. So to fix this, I'm going to select the wall that is blocking the camera here. And I'm simply just going to disable the mesh render. Under the components here, I'm just going to click this little toggle box next to the name. And there we go. So now the component that handles all the work of making sure that this cube is visible is now told to take a break. Don't worry about it. Therefore, making it effectively invisible while still maintaining its box collider, so that way it doesn't fall out the front. Also, the camera's a little low. I want it more centered in our box, so as we move our cube around with our new controls, we'll be able to keep an eye on it. I'm going to select our camera, and I'm going to use the gizmo here to quickly move it up and back. As you can see, when you have a camera selected in Unity, a little preview appears down here at the bottom right, which allows you to get a good idea of where you want it to be. That looks good. I'm going to go ahead and hit play just to make sure. Wonderful. Nicely framed. All right, now let's take a little break here. Let's look at our hierarchy. It's getting a little cluttered. We've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 objects in here, and we're almost halfway filled up our hierarchy. If we were making a real game, we would have a lot more than 30 game objects or however many this hierarchy window can hold. So we should probably start organizing our scene a bit. I can go up to our empty game object here that we created all the way back at the beginning, and I can give it a name like box. Now I can select the platform, and holding down Control, select all the other game objects that compose our box. And then I can click and drag and drop onto the box game object. There. Now all 6 walls of this box are children of the box game object. The box game object doesn't have any components. It's just a name and a position in 3D space. This is nice because if I ever want to get rid of the box, I can just disable box and all of its children also disappear. I can turn it back on. If I want to make the box bigger, I can just scale the one single box game object and all the 6 children scale with it. I can make it smaller, bigger, move it around. So the parenting and child system is very useful for not just organizing your scene, but also manipulating multiple game objects all at once. I can also go ahead here and click the little collapsible arrow next to box and clean up our hierarchy window quite a bit. All right, we're almost ready to start programming, but before we do that, we need to have Unity make a Visual Studio solution. Okay, what was any of that I just said? Again, please don't get discouraged or overwhelmed. I will break it down for you. Visual Studio is essentially just a text editor. However, it's specialized for programming. When I say the word solution, in Visual Studio, that is referring to a collection of script files that make up your game. And when I say script files, those are files that contain lines of code which create components. So again, to reiterate, game objects are given functionality by attaching components. You create components by writing scripts. When all those scripts are gathered together under one project, that is called a solution. You don't need to worry about it too much because Unity has the ability to create and manage Visual Studio solutions on its own. It's important that we set this up now, have Unity create a solution for us, because solutions are needed to take full advantage of Visual Studio's helpful features, including its error checking functionality. Okay, so let's look at some of the settings here to make Unity create a solution for us. During this process, Unity may become unresponsive for a moment or two. That's fine. That's just because it's doing all the background work to build a solution file for us. All right, to start, we're going to go up to File and Build Settings. If you're working on PC, Mac, or Linux, this one should be the default selected as our platform of choice. On the right here, you see a checkbox for Create Visual Studio Solution. We want that checked, and then just go ahead and close the build settings. One last step here, we're going to go up to Edit, and then Preferences. And then under the External Tools menu here, we want to make sure that Visual Studio Community 2019, or whatever version that came installed with Unity when you installed it, is selected. So with those two things confirmed, we should be good to go. All right, let's get cooking. So we're going to create our first script. Again, scripts are assets, and they should be organized as such. Create a new folder for your scripts. And right-click, Create. And right there at the top, right under folder, is C# script. I'm going to go ahead and name this Cube Controller. I'm not going to put any spaces in there. It'll just make it easier when we're in there programming. There, I've hit enter, and Unity has created a new script, It has generated the base code for us to start with, and it should have generated a solution file for us to use in Visual Studio that will bring out its full potential. Now let's add our cube controller to our cube as a new component. I'm going to select the cube, go down to the bottom where it says Add Component, and now I can search it. Cube, and there we are, Cube Controller. And here we are, just under the list of all the other components, we now have our custom component, the Cube Controller. Unlike all the other ones, it does not contain any fancy settings or values or properties or anything like that. And that's expected, we just made it. But now we're going to go into Visual Studio and we're going to start actually writing code that will expand upon our controller component and allow us to give it functionality. So to do that, I'm going to just double click our Cube Controller script. And there he goes. It opens up Visual Studio on its own. All right, now if this is your first time opening up Visual Studio, you may not see this. It's probably going to ask you to sign in using your Microsoft account. If you're working on a Windows computer, you don't need to make an account. You should already have one. You just sign in using your Microsoft credentials. If you don't have a Microsoft account, you can register for one for free online. Yeah, once you're all signed in, if you still don't see your Cube Controller file open here, just close Microsoft Visual Studio and double click on your file again. It should reopen, and this time it should load up cubecontroller.cs. Okay, before we start getting wrist deep in coding here, let's take a little break and talk about programming theory. Simply, I'm going to ask the question, what is programming in Unity? Like, what is it? What does it do? Simply put, it's writing up instructions that Unity then follows. Hence the name script. Unity is following the script that you wrote for it. A lot of instructions that you can write in scripts can automate things that you can do in the editor, such as creating and destroying game objects, transforming them, changing the color or brightness of a light, change the look of a material, play animations, play sound effects, start particle effects, and load new levels. You can also create and manage non-tangible elements of our games as well, like health points or HP, player lives, a game world's economy, or artificial intelligence for NPCs. Okay, let's take a look at this new script and try and understand what we're looking at. Again, everything we see here was automatically generated by Unity when we created our script. To start off, these first 4 lines here, these using system collections, using system collections generic, using Unity engine, and public class cube controller, you can essentially ignore these for right now. What we want to look at is the code that are within these brackets. Here, I'll type it here. These left and right brackets, also known as open and closed brackets. All the code written between these 2 brackets is called a block of code. By writing your code in blocks, you're able to section off code into different segments to keep it categorized into what it does. Let's take a look at this first block of code called void start. I'm not going to go into explaining what void means, but start is a familiar word. We all know what that means. And we have these little parentheses here, and then we have the open and closed bracket. And we have nothing in between, so right now it does nothing. And now Unity's been really considerate, and it's left us a little note up here at the top. Start is called before the first frame update. What this means is whatever code we write between these open and closed brackets will run only one time. It runs before the first frame of the game starts. It's after everything has been loaded, but before the game actually begins. Next, we have void update. Update is called once per frame. Well, a frame, as a lot of you may know, is every time the game renders something onto the monitor, renders a picture onto the monitor. Most games run at 60 frames a second. So whatever code we have written here in void update, this code will happen 60 times a second. Every time a new picture is displayed on the monitor, this code runs first. All right, a good practice for coding is to start planning your workflow. Give yourself goals. Write what you want to achieve in basic human language, so that way you can stay on task. To do that, we can leave ourselves comments. That's what these green lines are up here. Both of these lines are green, and they start off with 2 forward slashes. These 2 forward slashes lets Unity know that everything after them can be ignored. Unity doesn't care what's written after these 2 dashes. Once we start a new line, though, then it starts caring again. So using these comment lines, we can start adding code that's only for us. All right, so using comments, let's write out our goals for this script file. Every frame, we want to check if any key from WASD is being pressed, and if so, move the cube in the corresponding direction. Fairly simple. Check if any key from WASD is being pressed, and if so, move the cube in the corresponding direction. Now, we'll always have this as sort of like a lighthouse. Let's start with our first task. Check to see if a key is being pressed. We're going to do that using something called an if statement. The way an if statement works is we type the word if, and then we write something in parentheses. And then we need to have another block of code under it. The way it works is the thing we write in the parentheses needs to be something that the game can check on to see whether it's true or false. A very good use of an if statement would be to know whether or not a game over has happened. You have an if statement that checks to see if the player's health is equal to 0. And if the player's health is equal to 0, then it does whatever code we write in here, which could be to have the character faint and bring up a game over screen, for example. But for this instance, we're trying to see if a key is being pressed. So in order to check to see if a key is being pressed, we type this. Capital I input dot get key, parentheses, capital K key, capital C code dot W, close parentheses. Okay, now you may be thinking to yourself, how was I ever supposed to figure that out? Well, here's a little insight into being a programmer. A lot of your job is going to be Googling things. Like, honestly though, you're not going to know these things instinctively. You just have to experiment and research. Unity has a huge user manual, which I'll talk about later, but that's your main resource for looking up how things work and how to achieve certain results. But for anything you can't find in there, simply Googling what you're trying to do, such as I could Google Unity, C#, how to tell when a key is being pressed. And I will get a large result of people who have been looking for the same answer. Lots of useful forums where those people have already gotten the answers they're looking for. And chances are it's the answer you're looking for as well. Don't feel dumb if you don't know how to do something. No one expects you to. You have to find out on your own. That's the thing. It takes your initiative to hunt down a solution on your own or get creative and find interesting ways to achieve what you're trying to do. In the meantime, I'll try and break down what we're looking at. Input handles everything about player input, keyboard controller. Get key, it looks to see if there is a key. And then key code, we're describing which key, the W key. So what it's doing right now is it is looking to find the current state of the W key. If we're not pressing the W key, it's false. If we are pressing down the W key, it's true. And like I discussed before, if it comes back true, the line of code in between these blocks gets run. If it comes back false, the program skips this block of code and just keeps going without it. All right, so we've achieved our first step. We've checked to see if the W key is being pressed. And if so, now we need to move the cube in the corresponding direction. All right, so that's our new goal. We need to write code that will move the cube. All right, so I'm going to copy and paste this next line of code. All right, it's going to look like a big jumble of code that you may not understand at all, but don't worry, again, I will walk you through it and break it down and try and make it more legible. Copy, paste. Okay, so this is the code that will move the block. I'll start at the left and move right to describe it. This, when I type this, I am referring to this component, which is the cube controller. Dot GameObject. This means I'm now referring to the game object that the component is attached to. When we go back to Unity, that game object will be the cube. And now get component rigid body. What this does is it's telling Unity to look through all the components within the cube and find a component named rigid body. Once it finds it, we're going to then add force. Add force gives the rigid body a little kick. And now within these parentheses, we're going to be telling Unity what direction we want that kick. Vector 3. A vector 3 is kind of a shortcut way of writing three numbers. Vector 3.forward is the same thing as me typing 0-0-1. Now, does this seem familiar? Our transform component uses three values like this: x, y, and z. Remember that x is left and right, y is up and down, and z is forward and backwards. As you can see here, I mouse over it and a little helper box pops up here. Shorthand for writing 0, 0, 1. So again, to recap, a vector 3 is essentially a container for three numbers. When I say forward, I mean 0, 0, 1. If I said backwards, it'd be 0, 0, negative 1. But we want the W key to push the block forward. So we're going to keep it the way it is. Oh, and last but not least is the semicolon. The semicolon lets Unity know that we are done with this line of code, and it should go down to the next line. All right, so now we've completed our goal for the W key. We have an if statement that checks to see if the W key is pressed, and if it is, it adds a little bit of a kick forward to the cube. Okay, now before I move on and do this for the other keys, A, S, and D, I want to take a look at our code, and I'm going to realize that it is not very well optimized. This part right here specifically, get component rigid body, what this means is multiple times a second, potentially hundreds of times a second, Unity is going to need to search to find the rigid body component in our cube in order to give it a little kick. This may not be something you'll know naturally, but with a little bit more experience programming, you'll learn that get component is a very expensive process. It takes a lot of processing power to search a game object to pull a component out of it. So expecting Unity to do this hundreds of times a second is pretty taxing. We may not notice it with only one component like this, but if we have dozens or potentially hundreds of game components that all have poorly written code like this, it's going to start slowing down and chugging. So right now what I'm going to do is I'm going to create something called a variable, so that way before the game launches I can have Unity find the rigid body and store it somewhere. So that way it doesn't need to keep finding it constantly. Unity only has to find the rigid body once, and then we can very quickly get it whenever we need it. So to create this variable, I'm going to go up here right underneath public class. I'm going to create a new line under the brackets here, and I'm going to type this. I'm going to type private rigid body, and you see that Visual Studio is starting to help me. It's trying to autocomplete. It knows I want rigid body. I can just hit enter. That is a functionality brought onto us by having a solution. That's why we wanted to do that. Okay, so private rigid body, and then a name. I'm going to call it rigid body. That's pretty easy. And we're going to give it the semicolon to know that we are done with that line of code. All right, so now let's take a little look at what I just typed. Private determines what type of variable I'm making. There's two types. There's private and there's public. Private is for variables that only this component should be able to edit. Like, there's no reason why the sun in our game should be able to change what the rigid body is in this component. So I've set it to private. I don't want any outside influence affecting this. The next word, rigid body, this is the type of variable. This describes what we're going to be holding inside the variable. Again, variables are like boxes that hold data. If I change this to say int, an int variables, this is short for integer. Integers, for people who might need a reminder, are whole numbers. 1, 5, 15, 24, that's an integer. But that's not what we're doing right now. We are doing rigid body. That is what we are looking for. So right now the rigid body variable will start empty. It won't hold anything. But now we're going to write some code that'll fill it with the rigid body from the cube. So inside our block of code here under start, I'm going to copy this line of code all the way up to the add force part. If I just copy this bit of code, it ends right when we get the rigid body. So I'm going to go up here and I'm going to first type up the name of our variable, underscore rigid body, space, the equal sign, which is going to assign it a value. And now I'm going to paste. And last but not least, give it the semicolon. There. So now what we've done is we've created code that at the start of the game, after everything is loaded, but before the first frame has been rendered, this component, the cube controller, will search through all of the components on its game object and bring back the rigid body. And when it finds it, it's going to give it to our rigid body variable. It's going to store it inside there. So now whenever we want it, we instead of writing this big line of code, which is very processor heavy, we can just write this. So I'm going to copy underscore rigid body, and I'm going to select all of this code here and replace it. There we go. No errors. Okay, so now 60 frames a second, maybe even more. What'll happen is it just simply goes and grabs the rigid body that we have stored up here and puts it down here. And then it adds the force to kick it forward. There, now our script is a lot cleaner and more efficient. So next I'm going to copy all of this code here, Control C, and I'm going to paste it 3 more times, giving us a total of 4. 4 keys for WASD. So now I'm just going to go ahead and I'm going to change these. I'm going to edit them. So instead of W, I want A. Instead of W, I want S. And then instead of W, I want D. WASD. So now we're going to check for all 4 of our keys. And now I need to change the directions. A is going to be left. Left. There it goes. S is going to be backwards or back. That's another good reason about the autocomplete. Like you see, I thought it would be called backwards. So we have forward, backward. But nope, backward is wrong. The autocomplete lets me know that back is the word I want. And vector3 dot right. Okay, so we have W goes forward, A goes left, S goes back, and D goes right. I'm going to Control S to save, and now I'm going to head back to Unity. All right, as you can see here, Unity is compiling our new script. Compiling basically means it's reading the changes we made, and it is preparing it so that way it can be run in real time in the game. All right, we can see here we have our cube controller selected, and on the right we can see a preview of all the code we wrote. Now let's test it and see if it works. We'll let our cube fall to the ground. Now, even though it doesn't look like anything's happening, our script is running. Every single frame of the game, it is checking to see if W is pressed, A, S, D, and it's running the code. Since none of the keys are pressed right now, they're coming back with false values, which means the code is not running any of the code inside the blocks that we made. But now I'm going to hold down the W key and we'll see what will happen. Nice, there it goes, yeah. S, D, and A. Yep, and I can go ahead and I can hold down combinations of them, really get this thing whipping around here. Nice, there we go. Yeah, that feels good. It is officially a game now. It's not much of a game, but it's a game. Well, all right. At this point, I want to take a little break. If you have been following along thus far, I just want to say congratulations. Give yourself a pat on the back. You are now officially a programmer. You have written code and you've put it into your game object in the form of a custom component, and you've now made it so that way you have an interactable piece of software. You could essentially compile this, sell it on Steam, and get a bunch of bad reviews when people realize that it's just a simple cube simulator. But still, the fact remains that you made something. You started with nothing, and you've written your own code to allow functionality and interaction with this program that you've made. And now you can start building things on top of this to make it more interesting. like I think our last task for this evening is going to be adding a jump functionality to the cube. So let's hit the play button to stop the simulation. And let's go back to Visual Studio. All right, creating it to jump is going to be fairly simple at first. I'm going to go down. I'm going to copy the code here because essentially it's the same thing, right? Let's go ahead and create some new comments. Check to see if the spacebar is pressed, and if so, move the cube up. So copy and paste, because it seems like a pretty similar task that we're trying to achieve. Instead of the D key, we want to start typing space. There we are, space key. And now instead of forward, left, right, or back, we want up. Yep, there we go. Also, we want this to be a jump. So we are going to need to change the code up here. This checks to see if the key is pressed every frame, like being held. So what'll happen with if we keep this the way it is right now, if we hold down the W key, the cube will just shoot upwards infinitely. This is going to be good for like maybe a jetpack effect, but we don't want a jetpack. We want a jump. So we're going to change get key to something similar. We're going to go dot get key down. Sort of think of it as like a sibling to get key. When get key returns true as long as the key is being held down, get key down only returns a value of true if the key was pressed that frame. So what that means is if we press and hold down the space bar, it'll only come back true the first frame we push the space bar. We have to then let go of the space bar and then press it again if we want to have it come back true. So that'll prevent us from holding down the space bar and the cube just flying off into space. So let's go ahead and hit Control S to save. And let's go back to Unity. And it'll do a quick compile here. That was even faster. I didn't even notice it happen. And now I'm going to go ahead and hit play. Now, I kind of foreshadowed that this wasn't going to be as simple as that, and we'll see why here. I'm going to go ahead and hit spacebar. It seems like nothing's happening. Our code isn't broken. We didn't get any errors. Nothing stopped us from playing the game. If we had errors with our code, Unity would not let us start the game. But it did, so everything's working properly. It's just we're not seeing the effect. The reason why is because the amount of force that we're using to jump. Let's go back and look at our code. As I mentioned before, vector 3 is sort of like a shorthand for 3 numbers. Vector 3 up is the same thing as writing 0-1-0. That's 0 in the x dimension, left and right, 1 on the up and down dimension, and 0 on the forward and backwards, the z dimension. So the key thing here is the number 1. 1 is not a lot of force. When you consider gravity, gravity pulls downwards at about 9.86 units a second. So you can imagine that when every time I push spacebar, the cube gets a kick of 1 unit of force upwards while receiving negative 9.86 downwards. Like gravity's going to win. So what we need to do is we need to kick up the strength of that. Within the parentheses here, I could start writing mathematical equations. Like instead of vector 3 dot up all by itself, I can do vector 3 dot up times, using the asterisk key, times 500. What it does is it takes 0, 1, 0, and times all those numbers by 500. So 0 times 500 is 0, 1 times 500 is 500, and 0 times 500 is 0. So that's essentially writing this is the same way as writing 500 up. So if we have 500 units of force fighting against negative 9.86 a second, I think we're going to win and we might actually be able to see a jump. However, what if 500 isn't enough? What if it's too much? it would suck a lot to have to come back into Visual Studio and have to constantly change this number and then save and recompile, go back to Unity. What we can do instead is we can have a variable be a stand-in for this number. And not only that, but it can be a variable that we can change inside of Unity. Unlike our other variable, instead of being private, I want this to be public. A public variable can be seen inside of Unity and be changed in the editor. Also, I could maybe add power-ups someday that gives me greater jump height. So being able to allow outside objects to be able to change this variable could be very useful. So let's do public, and we want to create not integer, because although whole numbers would probably work for this case, we want to be able to have, usually you'll want to have more fine-tuned control over your numbers. So we're going to use float instead. Float means decimal numbers. Things like 0.1 or even 9.457.256. You know, float is a decimal number. We can get really detailed and minute with our jump force here. So again, public float, and I'm going to call it jump force. All right. And I'm going to give it a default value of 1. All right, you may have noticed that private variables I put an underscore in front of, and public variables I don't. That's just so that at a quick glance I can see what variables are private and which ones are public. If it has an underscore, it's private. If it doesn't, it's public. Okay, so now we have a variable called jump force that we can change inside the inspector in Unity, and we'll use this to modify how high we jump. I'm going to go ahead and replace the static 300 number with jump force. There. So now it'll default the 1, which means it won't make any difference. But then once we're inside Unity, we can then change it inside the inspector and type in whatever number we want, and that'll allow us to very quickly experiment and find the perfect amount of jump force. So I'm going to do Control S to save, and I'm going to return to Unity. Again, a very fast compile. Not even sure if it did anything, but let's check. Let's click on our cube, and we look down, and yep, there it is. Our cube controller now has a jump force variable that we can see. Not only can we see, we can also edit it. I can click and drag on the jump force name, and I can move it left and right to slide it like that, as if we were up here in the transform section, or I can manually type it in. I think 500 was a pretty good guess, so let's do that first. 500, enter, and now let's go ahead and hit play. All right, our cube is coming to a stop. I'm going to go ahead and move it using WASD to be a bit more center. And now I'm going to hit spacebar. There we go. Perfect. 500 is actually really good. I could spam the spacebar key to really get as much air as we want. This would be a good way to implement something like a double jump feature for a character, like in a platformer. Yeah, like right now it's a little too easy to hit the ceiling. I'm going to go ahead, go down the jump force here. I'm going to change it down to maybe 50. I'm going to hit enter. I'm going to click back in the game window here, and I'm going to hit spacebar again. Oh, very little, but you can see it. So I'm going to try smashing the spacebar as much as I can. Oh, I can barely get off the ground. Okay, I'm going to try maybe 100. Enter, and spacebar. There we go. Now it's a bit more manageable. Takes more work. It's harder than the 500, but it's doable. Okay. Still, it's a little tight. Let's say maybe 250. Let's spacebar. There we go. That feels good. So now I can start moving around WASD with my fingers and then use my thumb to hop. And I can really get this box flying. All right. So one last thing before we stop here. I've covered almost all the elements. We have game logic, we have 2D art, we have 3D art, and we have player input. The one thing we don't have right now is sound. I'm just going to do that really quick just to show how you might add sound effects to your game. I am going to right click in the assets folder. I'm going to create a new folder, and I'm going to call it SFX, shorthand for sound effects. I already downloaded one. I'll bring that up here in my file explorer. In my downloads folder here, I'm going to go ahead and it's called boing.wave. Go ahead and bring that down here. release, and Unity has added it. I can test it. I can select it here, and then in the inspector, I can look at all of its information. I can hit this little play button down here. There we are. Perfect. And now I can add this to the cube. I selected the point light. Let's go to the cube here. And I'm going to add it by adding a new component, and it's called the audio source. The audio source component allows us to emit sound. So I'm going up here. The audio clip is the sound file that will be used. I can click on the little dot here, and there it is, boing, the only sound in the game. Double click, it's been added. And then I can do things like play on awake. I don't want that on. What that means is it'll play the boing sound as soon as the game starts. I don't want that. I only want it to play the boing sound when I want it to. And yeah, I think we can leave all the other settings as they are. Let's go back to our code. And we're going to do kind of what we did with the rigid body. I'm going to copy this. We want to have a variable that can hold the audio source. So instead of rigid body, we want audio audio source. And I'm going to name it underscore because it's private, underscore audio source. All right, and then again here, void start. We only want it to go fetch it one time because it's expensive to do on the CPU. Copy and paste. And then instead of storing it inside the rigid body variable, we want to store it inside our audio source variable that we just made. And instead of having it search for a rigid body component, we want it searching for an audio source. Okay, so now when the game's done loading, but it hasn't started playing yet, it'll search our game object, our cube, for an audio source component and then store it inside our audio source variable. And then underneath our line of code here that makes the cube go up, we can add some code here that'll make the audio source play its sound file. We'll access our variable audio source, and we want to do dot, and then it'll bring up all the things that we can do with audio sources. And there's play. Play needs to end in parentheses. And then we hit semicolon to let it know we're done, and that should be it. So when we press the space bar, our cube will jump and the audio source will play. Control S, save. Let's go back to Unity and let's test it. I'm going to go ahead and hit play and I'm going to hit spacebar. Yep, there we are. That is not being added in post effect or anything like that. That is happening thanks to our script. I could add more code and more sound effects to handle things like collisions. Have it so every time the cube collides with something, check to see if it's going fast enough. And if it's going fast enough, play a collision sound effect. But I think this will get us... But I think this will serve us well enough for tonight. Well, that'll do it. Not much of a game. We could maybe add a couple things like power-ups to increase the speed of the cube, the jump height. Instead of having the cube trapped in a little box like this, we could maybe create a huge monkey ball-like course that you have to navigate through and have a goal at the end, or have pellets that you need to absorb that makes the light brighter. You know, there's tons of different ideas that you could use to actually gamify and make this more fun. But it's still important to recognize that we've achieved the basics of making a game. You can now navigate around the Unity editor. You know what you're looking at. You understand the concepts of game objects. We've looked into how you can then manipulate those game objects using the inspector and the transform component to move things around, scale them, rotate them, and use them to build your game world. And then we just charged head on into programming, and you saw a quick demonstration of what it takes to be able to recognize input from the character and then have things respond in the game. I hope this has helped ease you into understanding the game development process and maybe even inspired you to make something on your own. Before we go, I'd like to pass on some final advice, as well as some resources to help you continue your journey into becoming a game dev. I mentioned it before, but the Unity user manual is indispensable in the sense that it has just huge volumes of knowledge on anything you'd ever want to know about Unity. On the left, you have a guide that can kind of help break you down into different sections. You have input, 2D, graphics, physics. Anything you'd want to know, you can look it up here. There's also a search bar up at the top. And also when you search Google, again, a lot of the results are going to bring you to pages in the Unity manual. There's also the Unity Learn website. That's learn.unity.com. This is a website that is just full to the brink of just really useful tutorials, interactive classes, and it also monitors your progress. So if you sign in using your Unity ID, you can keep track of all the lessons and tutorials that you've completed. It's a nice visual way of seeing all the knowledge you've accumulated. Another really nice thing about Unity Learn is that it used to be a paid-for service. You used to have to pay to get access to the higher-end tutorials. However, due to the pandemic, Unity has opened those doors and made this all free knowledge for everyone. This is a very, very good resource. I learned how to program using Unity Learn. The class I had has since been retired, but I'm sure that there's plenty of good replacements for it right now. I'd also really like to promote the Tucson Game Developers Group. They're a large group of local game developers here in Tucson that are focused on being a supportive, inclusive, and safe community for anyone at any skill level who wants to make games. It doesn't matter where you live in the world, they'll accept you. You'll find that your progress growing as a game developer will be so much faster and well-nourished if you're in a community of like-minded people. It's a great way to share ideas, get inspiration from others. They also hold monthly meetings. Oftentimes, these meetings will have guest speakers from the industry. And they also host game jams. A game jam is when a bunch of people come together, form small groups, and then work together on making a game in a short amount of time. They recently completed the Global Game Jam for 2022, and the submissions were really incredible. I highly recommend you give them a look. Just go to TucsonGameDev.com. Here you can read up on the group, see about their meetings and events, as well as get a link to their Discord channel, which is where all the meetings are held. All right, I'd also like to go over the software packages that are very useful for creating games. I'm going to start off with programs that are going to require to be paid for. However, they're still going to be on the relatively cheap end. First off, for 3D modeling, I'd recommend Maya LT. For people who aren't familiar with Maya, Maya is a industry-leading 3D modeling application. It's used by big budget movie studios for special effects and professional AAA studios. They have a light version called Maya LT. It's essentially the Maya software, but it's been tooled down to only include the tools needed for game development. It's targeted towards indie developers who don't have the big budget of AAA studios, but still wants to have a professional industry tool. It's $35 a month if you go month to month, or $23 if you sign up for a year at a time. You can save $1 a month if you sign up for 3 years, but I don't know, that's up to you. Okay, now I'm going to look into 3D sculpting. 3D sculpting is like 3D modeling, but it's more organic. It's like working with clay. In today's day and age, it's pretty common for 3D artists to not only have a 3D modeling package, but also have a 3D sculpting package. You can create the general low poly version of the mesh inside your 3D modeling package, and then you can take it into your sculpting program and then start smoothing it out and adding details. 3D sculpting, a good example would be things like adding pores to the skin of a human character, or adding a zipper or stitching onto their clothes. You can get really detailed and make some really impressive looking models with 3D sculpting. Mudbox is the cheap entry level to this, with month to month being $10 a month, or if you sign up for a year, that's $8 a month. On the higher end is ZBrush. ZBrush is pretty much accepted as the leading standard for 3D sculpting. Mudbox is great, but ZBrush is leading the charge. ZBrush has all the bells and whistles and is fairly common throughout the industry. However, it is more pricey. We're looking at $40 if you go month to month, or $30 a month if you sign up for a year. If you can save up about $900, you can buy a lifetime license. What that means is you pay the one-time fee of $895, and then you get the program for life. The downside is that you don't get any updates. So as ZBrush continues on, if you buy it in 2022, by the year 2030, assuming we're all still here, you will not be able to get all the cool features that the new ZBrush 2030 has. Next, moving on to 2D art, for things like creating textures, I would recommend the Adobe Creative Cloud, specifically the photography bundle. It's $10 a month and comes with both Photoshop and Lightroom. Photoshop is great for image manipulation and creating any kind of textures you want, whether they be realistic or stylized. And Lightroom is useful for importing photos from your digital camera. So if you're out there in the world taking photos of real life locations to be used for textures in your game, Lightroom's really good for being able to optimize the quality of your photos. All right, next, moving on to free software. A lot of the programs I mentioned in the paid portion can be done just as well, if not better sometimes, in free applications. Starting off with 3D modeling and sculpting would be Blender. Blender is a great versatile tool that is open source, meaning that it's developed by a community, and it's just widely open to anyone who wants to use it. It's just a free download and you go. As I mentioned, you can do basic modeling by hand, and it also has plenty of really powerful sculpting tools as well. Not to mention, it also contains a lot of built-in really powerful rendering tools and physics simulations and all the neat effects that you won't find in Maya LT. Right. For 2D art, I'd first recommend Paint.net. It's essentially a free version of Photoshop. Not as powerful, but it has all the key features that you want from Photoshop. Being able to quickly adjust the lighting, the vibrancy, the hues, being able to create layers so that way you can stack effects, and be able to edit parts of your image without affecting others. Also under 2D art would be Photopea. Photopea is incredibly impressive in the sense that it is entirely browser-based. You don't need to download anything or install anything. You just simply go to the website and get to work. It can do almost everything that Photoshop can do, as well as some things that Illustrator can do. If you're not familiar with Adobe Illustrator is used for professional designers, creating very clean, sharp graphics. Anyway, Photopea does it all. For music creation, I would recommend GarageBand. Unfortunately, it's going to be pretty difficult to get a hold of if you're a PC user. I don't even know if you can get it on PC right now. But if you have a Mac at all, if you have a Mac or even an iPhone, you should be able to have GarageBand for free. I'm not super experienced in it, but I know plenty of people who have created amazing music in it. This isn't so much for music creation, but more just audio editing in general. I'd recommend Audacity. Audacity is great for editing sound files, whether they're ones that you've recorded yourself with your own devices or ones that you've found online. If a sound is too long or too noisy, Audacity is great for trimming it down or removing the noise. It can also export into many different file types. Speaking of sound effects, I would recommend freesound.org. It's a large archive of user-submitted sound effects, a lot of them under the Creative Commons license, meaning that you can use them for free. I'd just suggest that if you do use them in a game that you end up selling, credit them somewhere. And that's where I got my boing sound effect, actually. And finally, game engines. I've talked at lengths about Unity. It's the one I have the most experience with, and I think it's great. I think it's great for beginners. I think it's great for seasoned developers as well. It's not a bad place to start, that's for sure. And also, now that you've watched this lesson, you know what you're doing in it, so that's a plus too. As far as pricing goes, Unity is free for anyone to get started. As long as you or the company you're making games for earned less than $100,000 the previous year, you're good to use the personal license for free. However, if you or the company you're making games for did make over $100,000 the previous year, you will need to buy a pro license. The Unity Pro license costs about $33 a month in the form of a $399 down payment for the entire year. All right, and last but not least, the Unreal Engine. This is another very popular one right alongside Unity. I'm not highly experienced with Unreal at the moment, but it is a very popular option. It's free to use, very much like Unity, up until the point in which the game you make with it earns you more than $3,000 in a financial quarter, or essentially $1,000 per month. Then Epic is going to want a 5% cut of those sales. So let's just say theoretically, if you made $10,000 in 1 month off of selling your game, that's pretty good. You're doing a good job. But Epic will take $500 of that $10,000. So you still get the pocket $9,500. Whew, all right, we made it to the end. Thank you all for sticking with me this long. I really hope that you were able to follow along well. I hope it wasn't too confusing or, too overwhelming. I want to thank Bookmans and Fangamer again for giving me this chance to share this thing I'm really passionate about, and I really hope some new game developers come out of this. If you enjoyed yourself and want more streams in this style that delve deeper into various areas of game development, be sure to let us know on social media at Fangamer and at Bookmans. If you're watching this on YouTube, please like the video and leave a comment letting us know what you'd like to learn more about. It's hard to know how many people this actually helps, so please make some noise if you think this is something we should do more often. If you'd like to know more about me or just follow me on my socials, you can go to jacko.com. That's jack-o.com. If you have any questions, need help, want to share a cool thing you made, or just to say hi, you can shoot me an email at jack@fangamer.com. All right, have a nice weekend, everyone. Stay safe, be excellent to each other, and I can't wait to see what you make. Good night.